Hi, Year 9. Our last topic for Chapter 4 is how do we use all the trig that we have been learning over this last chapter and apply it to solving real-world problems, okay? So for some of the real-world problems that we might see, this one, we are looking at an angle of elevation. So an angle of elevation means if this was the ground, so if you guys look down at this photo here, where I'm drawing the red dotted line, that would be the ground. So an angle of elevation goes from the ground upwards. So now I'm looking at this angle right here from the ground upwards of 32 degrees. This is an angle of elevation, okay? So I elevate from the ground. So if I look at this angle of elevation of 32 degrees, and if you look toward the castle wall, you wind up getting this height that we're not sure of. So here's our question mark. We don't know how tall the castle wall is, but we know that we're standing 25 meters away from the wall. So if we take a look at this picture, we have a right triangle in the corner of where we're standing to the wall and then up to the top of where our eyesight can actually see. So here's our right triangle, and the question is, find the height of the castle wall. So you guys can actually use trigonometry, so your sine, your cosine, and your tangent, in order to figure out how tall the castle wall is, just based on where you are standing and what the angle is, okay? So let's take a look at this one. Go through the same steps that we've been using over the last couple days. First, we've located our angle, 32 degrees, and circle it right there. Label the sides. So if you're standing at the 32 degree mark, we want to know something about the castle wall, and that is opposite from you. So we're going to label that as our opposite side. We don't have the hypotenuse in this question, but we do have the adjacent side, because that's directly next to the 32, and it's helping to make that 32 degree angle. Also, identify what trig function you would use. So remember, your sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So what we have in this question is opposite and adjacent, so I'm going to use tangent. Let's go ahead and begin to set up our equation. So I've got tangent of theta is equal to opposite divided by adjacent, and I'm going to substitute in everything that I have. So tangent, I have 32 degrees as my angle. I do not know the opposite side, but I do know that the adjacent side is 25. Once I have the equation set up, my question is, how do I actually solve for what I want to solve in this question? I've done many different types of questions over the last couple days, so we want to know which strategy should we use. So in this question, our unknown is the opposite, which is the numerator. And a few days ago, what we wound up doing was if we wanted to get the opposite alone, we had to get rid of the denominator of 25. So what winds up happening is in order to find the opposite side, we have to multiply 25 by tangent of 32 degrees. So let's go ahead and pick up our calculator, and let's take 25 times tangent of 32 degrees. So if I clear my calculator, I have 25 times, and then in brackets I'm going to put tangent of 32 degrees. Let's see if we can do that. 25 times tangent of 32 degrees. All right, guys, so just looking back at the calculator, now that it's typed in correctly on this calculator, this one will set up as 15.6. So make sure on your calculator you're getting the same answer, 15.6. So coming back, let's just make sure that sounds realistic. 15.6, we're talking about meters. If you're 25 meters away and you're looking at about an angle of elevation of 30 degrees, would it make sense that this wall would be about 15 meters tall? Okay, so yes, that's a very realistic answer. Let's go ahead and take a look at one more example, going through the exact same steps. So for this example, we're looking at from a pedestrian overpass. Chris spots a landmark at an angle of depression of 32 degrees. So now, if you guys think about this angle of this dotted line that I'm drawing, let's think of that almost like the horizon, right? That's kind of a flat line that's parallel to the ground. An angle of depression just drops down from whatever line that you're referring to, okay? So an angle of depression is a drop, whereas the elevation is a lift. How far away is the landmark from the base of the 24-meter high overpass? So if you notice in this picture, we have 24 meters here. So this overpass, here's my overpass where I drew the red line, kind of like our overpass outside of Redlands to walk across Military Road. 24 meters off the ground. This one's a little higher, right? We have an angle depression of 32 degrees, and they want to know how far away are we standing. So what we really want to know is how far the horizontal distance. Okay? Again, we still don't want to know the hypotenuse in this question. So if I'm thinking about, let's label the sides we're looking at. So from 32, 24 would be our opposite. X is going to be our adjacent. And I don't want to know my hypotenuse. So opposite and adjacent allows me to use cosine. If we substitute in, adjacent over hypotenuse, excuse me. Oh, opposite and adjacent, that's tangent. Excuse me, guys, let's go back. Tangent is opposite divided by adjacent. Okay? Hopefully you're yelling at me through your computer screen. So let's go ahead and substitute in everything that we know. Tangent of 32 degrees. Our opposite side is 24. Our adjacent side we do not know, that's our x. And look at where our unknown is. Here is our x, which is in the denominator. So remember when we had an x in the denominator, in order for us to simplify x and isolate it, get it on its own, we had to divide. So we'll have to take 24 and divide by tangent of 32. This is bringing back all the steps that we've done over the last couple days, okay? So go ahead and grab your calculator. Let's take 24 and divide by tangent of 32. And we'll get about 38.4. We're talking about meters in this question, all right? So again, we're further away than the 24-meter drop, and that seems pretty realistic in this question. So it's great that we have double-checked that. And it says to round to the nearest meter, so I can leave my answer as about 38 meters. All right? So you guys will get to come across all kinds of questions where you get to pull back information from the last couple days and weeks at the end of our trait chapter. All right? Have a good night, guys.